In last lecture, we saw how hydroelectric power plant works. In this lecture, we will see what are the main parts of the hydroelectric power plant. Okay, or from this diagram, you can observe that the main parts are the dam. Okay, second is the penstock, third is the water turbine, fourth is the electrical equipment, that is generator. Okay, or there may be extra equipments like surge tank is there. Okay, we will see working of each of them in detail. The main constituents of hydroelectric power plant are, first is the hydraulic structure. Okay, obviously, which constitutes dam, spillways, then penstock, and surge tank. Second is the water turbine. Okay, various types of water turbines are there, like a reaction type or impulse type water turbines are there. Okay, and third is the electrical equipments. Okay, which are there to convert mechanical energy into electrical energy, that is generator, and to uh, and to integrate that generator to the grid. Okay, a substation is there. Okay, so we will see one by one each of the parts. Okay, the hydraulic structures in hydroelectric power station include dam, spillways, headworks, surge tank, penstock, and other accessory works. Okay, the main parts are dam, spillways, headworks, surge tank, and penstock. Dam is nothing but what? It is a construction which is uh, constructed to barrier for a store water. Okay, which is constructed to store a water. Okay, because of the dam, a reservoir will be formed. Okay, and these dams may be of uh, two types. One is the concrete or stone masonry type. Okay, means what? The dam is made up of using concrete or stone material. Okay, say stone or brick. And second is the earth or rock fill dam is there. Okay, we will see how they look like. Okay, the type and arrangement depends on the topography of the site. Okay, means what? Where to uh, build that dam. Okay, whether it is a hilly region, okay, or it is a uh, it is uh, it is near the what we can ground level. Okay, for example, if you compare the two dams, Koyna Dam, okay, which is in hilly region, and second is the Almaty Dam, okay, which is down the river, okay, in Karnataka. Okay, obviously their construction is different. Okay, there a masonry dam. Okay, a masonry dam may be built in a narrow canyon. Okay, where is the narrow canyon? Okay, means what? The distance between two hills is very narrow. Okay, दरी सारखं part आहे, तर त्या ठिकाणी masonry dam built केला जातो. Okay, masonry dam is nothing but what? It is made up of stones. Okay, and to bind those stones together. Okay, binding material is used. Obviously, it is a mixture of mortar or clay. Okay, and earth dam, and whereas second type is the earth dam. Okay, and it is best suited for wide valley. Okay, whereas where the wide valley is there, the height of the that particular hills, okay, on the either side of that valley are very low. Okay, in that case, earth dam is erected. Okay, we will see their photos, then you will get the idea how they will look like. The type of dam also depends on the foundation conditions. Okay, means what, by which material the ground is made up of, whether it is made up of basalt, okay, or it is just made up of a soil, okay? Whether it is strong or weak, okay, all these condition has to be considered. Local materials, okay, means what, suppose in hilly area most of the time the dam is made up of stones, okay, means what, the whether the availability of stone is local or transportation is required, okay, we have to uh, consider those things also. Occurrence of earthquakes, whether that particular hydroelectric power plant, okay, uh, going which is going to be erected in earthquake area uh, or not, okay, we have to consider that thing also. Okay, for example, in Koina, the okay, there are earthquakes, but the Richter scale of that earthquakes is very low, okay, under 4, maximum 4 Richter scale of earthquake is there, okay, means what, it is in safe area, okay, but if you consider the Himalayan area, okay, uh, where the Indian plateau is always colliding with the Tibet plateau, the major earthquakes are happening. Okay, means what? With those condition has to be considered. Okay, or whether there are other hazards are there, we have to consider those things also. Means what? त्या ठिकाणी काही खूप पाऊस पडल्यामुळे दरड कोसळणे वगैरे असं काही प्रकार वगैरे होतात का, ते सगळ्या गोष्टी ज्या आहेत ते पाहाव्यात. किंवा ढगफुटी होत असते का, एकदमच खूपच जास्त पाण्याचा फ्लो येतोय का, ह्या सगळ्या गोष्टी पाहाव्या लागणार. At most of the sites, more than one type of dam may be suitable, and the one which is most economical is chosen. Okay, there may be a site where masonry type dam can be erected, or uh, earthen dam can be chosen, okay, but which is the most economical is chosen, okay. Obviously the cost related to it, or the which dam gives the highest power output, okay, those things also have to consider. Obviously the power output is depending on the water head, okay. Okay, this is the masonry type, okay. This masonry type dam is situated in Andhra Pradesh. Its name is Nagarjun Sagar. It is the largest masonry dam in the world. Okay, this dam is largest in the world, which is made up of stone. Okay, you can read here. Masonry dams are dams made up of masonry, mainly stone and brick, sometimes joined with mortar. Okay, those are joined with mortar. Okay, they are gravity or arc gravity type. Okay, these are their types. Okay, arc gravity types means what, their shape is like this. For example, suppose uh, this is the river which we have to obstruct, the arc type will be look like this. Okay, धनुष्या सारखा आकार असतो त्याचा असा, अशा पद्धतीचं असतं. इतके डिटेल्स आपल्याला काही गरजेचं नाही आहे. The largest major dam is in India. Okay, Nagarjuna Sagar Dam. Second is the earthen or earth dam or rockfield dam. Okay, the largest in India and second largest in Asia. The dam's name is Banasura Sagar Dam. Okay, which is located in Kerala. Okay, you can compare those two types. Earthen dam, okay, how it is made up of, for suppose this is the ground, okay, and the earth, sorry, the river flow is there. Suppose this is the river flow, okay, then how it is constructed, okay, the main core part, 1 minute, the main core part first is built, okay, like this. Okay, this is the main core part, and then a slopy part is made on either side. Okay, its height is not that much of higher than as compared to machinery type. Okay, and it is situated where wide valley is there. Okay, if you uh, observe here, the valley is very wide. Okay, the valley is very wide. Okay, in such cases the earthen dam is built. Okay, next constituent is the spillways. Okay, spillways, sometimes what happens, very heavy rain will go going on hilly areas, and because of that huge amount of water is coming to the dam. Okay, and maybe the dam will overflow. Okay, that extra water uh, has to be sent to the river body. Okay, down the dam. Okay, uh, for safety of that dam. Okay, and for that spillways are used. Okay, I will show you that photo of the spillway. Okay, but before that we will read the information about it. There are times when river flow exceeds the storage capacity of reservoir. Such a situation arises during heavy rainfall in catchment area. Okay, catchment area means what? From where the water is coming to the dam. Okay, that is nothing but what catchment area behind the dam. In order to discharge the surplus water from the storage reservoir into river on the downstream side of the dam. Okay, spillways are used. Spillways are just a path which is goes through the dam. Okay, given to the given for the flow of the water. Spillways are constructed of concrete piers. Okay, it is made up of concrete on the top of dam. Okay, it is situated in the top part of the dam, and gates are provided between these piers, means spillways, and surplus water is discharged over the crest of the dam. Okay, I will show you the photo. Okay, here this is the reservoir. Okay, this is the reservoir, and this part is the spillway. Okay, this part is the spillway. This part is the spillway, and you can observe that this spillway part uh, is uh, is situated in the upper part of the dam. Okay, it is the inner part of the dam. Okay, means what? The inner part of the dam is of this type. Okay, this type. Okay. The way is created for the flow of the water. Okay, water will be flown through this. Okay, and this is situated in the dam itself. Okay, means what? If extra, oh my god, 1 minute. सर काय लाईट गेली म्हणजे बंद झाले सगळं ना. हॅलो अजय, हा येतं ऐकू ना. ओके 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 okay, means what? The if the water height is increased due to heavy rain. Okay, the extra water will be flown, will provided the path to these spillways. Okay, and you can observe here, this is the gate. Okay, this is the gate. Okay, when extra water is there, the water will be flown through the spillways, and when gates are opened, that water will go to the river directly. Okay, it is goes to the river directly. Okay, this part. Okay, this part is in the dam. Okay, this is the dam, major part of the dam. Okay, and you can observe that these are the gates. These are the gates. Okay, when these gates are open, the water will come through the spillways and goes to the river. Hello, Ajay. Okay, take it. Next is the headworks. Headworks means what? Lot of debris come to the reservoir. Okay, when water coming from the hilly areas. Okay, debris like wood. Okay, or plants, leaves. Okay, or any flowing material. Okay, which uh, flows on the water, okay, has to be removed from the reservoir, okay, else it will hamper the operation of the uh, turbine, okay, or turbine may get damaged, okay, and for that headworks is done, okay. The headwork consists of divergent structure at the head of an intake, okay, like a canal is built, okay, a canal is built along along the main dam. They generally include booms and racks. Okay, these are the booms. Okay, maybe booms are there or racks are there. Okay, for diverting floating debris. Okay, you can observe here. This is the debris. Okay, and these debris are diverged through the extra divergent path provided, like canals. Okay, sluices for bypassing debris. Sluices means what? You can say that it is a gates. Okay, when we want to pass those debris down to the river, okay, these gates are opened, which are connected to extra canals. And sediments and walls. Okay, sluices for bypassing debris and sediments, and walls for controlling the flow of water to the turbine. The flow of water into and through headworks should be as smooth as possible to avoid head loss or cavitation. Okay, most of the time where the water is स्मूथ, म्हणजे शांत पाणी असेल तर त्यातला कचरा काढायला सोपं पडू शकतं. म्हणजे अशाच ठिकाणी कॅनल किंवा हे स्ट्रक्चर उभं केलं जातं की त्या ठिकाणी खूप पाण्याची हालचाल नाहीये. फॉर दिस पर्पज इट इज नेसेसरी टू अवॉइड शार्प कॉर्नर्स. एकदम कडेला वगैरे जर केलं तर त्या ठिकाणी पाण्याचा फ्लो त्या भिंतीला किंवा त्या बाजूच्या एरियाला थडकून जास्त असतो, हालचाल जास्त असते, त्यामुळे त्या ठिकाणी शार्प कॉर्नरला उभा करत नाहीत ते ही स्ट्रक्चर. Sharp corners and abrupt contraction or enlargements. Okay, you can see it is extra. This is the extra canal. Okay, along with the main dam. Okay, is there. When debris will come, the debris will be removed from the water and it is allowed to flow through this headwork structure, that is canals. Okay, means what? Headwork consists of booms, racks. Okay, means what? Instruments to collect those debris or remove those debris, and a canal, okay, with sluice gates. Next is the surge tank. Next part is the surge tank. Obviously, surge tank is provided to relieve the penstock from the high pressure when the turbine is off. When the turbine operation is uh, abruptly off, okay, then that case surge tank is used. Okay, so what happens? Generators are providing energy to the grid, and if because of some problem in the substation or powerhouse, generator is turned off. Okay, so if generator's output is not present, in this case the turbine does what? The input water flow to the turbine is obstructed. Okay, it is stopped. Okay, and obviously when the input water coming to the turbine is stopped, the water quantity in the penstock, okay, because the penstock is connected to the water turbine, okay, means what? The output part is obstructed, means what? Water pressure in the penstock will be increased. Okay, and that may damage the penstock structure. Okay, even if it is made of steel, it may be damaged. Okay, and so in such cases, to relieve the penstock, from such a high pressure conditions, okay, a surge tank is built, okay, near to the penstock. Means what, the extra water will be diverted to the surge tank. Okay, you can observe in this figure, okay, when the generator is turned off, the turbine will be turned off and it will be shut down the gates, okay, so the water flow will be reduced, okay, and the pressure in the penstock will increase, okay, and in that case the surge tank or surge tank wall will open, okay, surge tank wall will open and the water will flow to the surge tank. Okay, some terminologies are there, okay, which may be asked in exam, okay, we will see related to surge tank. Due to motion, water possesses some momentum. This momentum is destroyed if the flowing water is suddenly brought to rest. Okay, when water is flowing through the pipe, it has some velocity, and when it is obstructed, okay, obstructed, that velocity will be become zero. Okay, and this obstruction will be there due to closing of wall. A very high pressure is developed on wall and in the penstock. This high pressure is followed by a series of pressure vibrations. Okay, pressure vibrations resulting in a noise in the pipe, and this noise is known as knocking. Okay, in exam they may ask what is knocking. Okay, knocking is because of this. Thus, other terminology is water hammering. Okay, the sudden rise in pressure has the effect of hammering action on the walls of pipe or penstock, and it is known as what, water hammer or water hammering. ओके, आतून जे आहे ते पाईपच्या आतल्या साईडला खूप जास्त प्रेशर तयार झाल्यामुळे आतून हॅमरिंग ऍक्शन सारखं त्या ठिकाणी होतं. हॅमरिंग म्हणजे काय, हॅमरनं त्या ठिकाणी मारल्यासारखं असं. This water hammer can burst the pipe. Okay, it will damage the pipe. Okay. In exam, what is knocking or what is water hammering will be asked. So what is the functions of surge tank? The first function, to control the pressure vibrations. Okay, means what, to eliminate knocking and water hammering due to rapid changes in pipeline flow, thus eliminating water hammer possibilities. And second is to regulate the flow of water to the turbine by providing necessary retarding head of water. Obviously, high pressure is also required, okay, when turbine is in operation, okay, to give highest possible mechanical energy to the turbine, the water pressure must be high. Okay, but when turbine is not in operation, that pressure must be reduced. Okay. Next part is the penstock. 1 minute. Next part is the penstock. Penstocks are open or closed conduits. Conduits means what? Pipes. Okay, and these are made up of concrete or steel, which carry water to the turbines. Okay, penstocks are pipes connected to turbines, and water will flow through them from dam. They are generally made up of reinforced concrete or steel. Concrete penstocks are suitable for low heads. Okay. Low heads means what? Low erosion is there. Okay, in that case, concrete penstock will be used. As greater, okay, for large head. Okay, when large head is there, means what, reservoir capacity is very high, means what, the pressure created by water on penstock will be high. Okay, in that case, concrete penstocks cannot be used. Instead of steel material is used to design the penstock. Okay. And the thickness of penstock increases with head or working pressure. Okay. Next part is the penstock protection itself. The penstock is the main part of the dam, and it has to be protected. Okay, and for that, surge tank along with automatic butterfly valve and air valve are placed. Okay, how they work, first we will read. Automatic butterfly valve shuts off water flow through penstock promptly if it ruptures. Okay, because of the high pressure, when penstock ruptures, okay, it will shuts off the water flow. Okay, air valve, whereas air valve maintains the air pressure inside the penstock equal to outside atmospheric pressure. Okay, there may be case of vacuum will create in the penstock. Okay, and because of that, what will happen? That penstock will bend. Okay, penstock will bend. Okay, and if we don't want to happen that with the penstock, then air pressure valve is used. Okay, when vacuum is created, air will be allowed to pass through the air valve to the penstock. When water runs out of penstock faster than it enters, okay, when output water flow is greater than the input water flow, then in that case what will happen? Vacuum is created. Okay, and which may cause penstock to collapse. Under such situations, air valve opens and it admits air in the penstock to maintain inside air pressure equal to outside air pressure. Okay, इनसाइड आणि आउटसाइड एअर प्रेशर जे आहे ते सेम असलं पाहिजे. दोन्ही थोडंफार तरी कमी जास्त झालं तर एक तर ते बेंड होणार. समजा आतलं प्रेशर आहे ते कमी झालं तर ते बेंड होणार, आणि बाहेरचं प्रेशर कमी असेल म्हणजे आतलं प्रेशर वाढलं असेल तर काय होणार? ते बस्ट होणार. ओके, मीन्स वॉट, आतलं प्रेशर वाढलं असेल तर सर्ज टँक ऑपरेट होईल, आणि आतलं प्रेशर कमी झालं असेल तर एअर व्हॉल्व ऑपरेट होईल. ओके, next part is the water turbines. Okay, water turbines. Water turbines are used to convert energy falling water into mechanical energy. Means what? Hydraulic energy or kinetic energy associated with the flowing water is converted into mechanical energy at turbines blades. Okay. The principal types of water turbines are: one is the impulse type and second is the reaction type. Okay, we will see in detail. Okay, in impulse type, okay, you can observe from the figure. Okay, in impulse time, a nozzle is there at the end of the penstock, at the end of the pipe. Okay, so a very high pressurized water, okay, will be collapsed or bombarded on the blades of the turbine. Okay, this is the Pelton wheel type turbine. Okay, I will show its photo how it looks like. Okay. Impulse type turbines are used for high heads where there is a high head. Impulse turbines are used. In impulse turbine, the entire pressure of water is converted into kinetic energy. Okay, in a nozzle, and the velocity of jet drives the wheel. Okay, jet means what? This water flow. Okay, very narrow water flow with high pressure is nothing but a jet of water. The example of this type of turbine is the Pelton wheel. Is the Pelton wheel. Okay, I will show you one type of Pelton wheel. Okay, you can observe here. This is the Pelton wheel. Okay, worker is standing near to the Pelton wheel. You can compare the size of the Pelton wheel. Okay, very huge size is there. Of, okay, of the blades. And when this jet of water, high pressurized narrow water, okay, water flow bombarding on the blades, okay, these blades, okay, it will rotate. Okay, this is a Pelton wheel type. Okay, second is the reaction term. काय doubts असतील तर विचारा. Second is the reaction turbine. Okay, reaction turbines are used for low and medium heads. Okay, for high heads, impulse turbines. काय झालं? हॅलो हॅलो, कोण बोललं का? हॅलो, माझा आवाज ऐकूचे का अजय?
हा येतोय सर.
ओके, काय डाऊट असेल तर विचारा. ओके, reaction turbines are used for low and medium heads, whereas impulse turbines are used for high heads. In a reaction turbine, water enters the runner. Okay, water enters the runner partly with pressure energy and partly with velocity. High pressurized with high velocity water enters the turbine part. The important types of reaction turbines are, one is the Francis turbine and second is the Kaplan turbine. I will show its their photos as well. Okay, Francis turbine is for low and medium heads. Okay, it consists of a outer ring of stationary guide blades. Okay, there are a stationary. Okay, remember stationary guide blades are there. Means what, two sets of blades are there. One is the stationary and one is the rotating, fixed to the turbine casing, and an inner ring of rotating blades. Okay, two sets of blades are there forming the runner. Okay, which runs, okay, due to the flow of the water. The guide blades control the flow of water to the turbine. Okay, means what, guide blades directs the flow of water to the runner or rotating blades. The water flows radially inwards and changes to a downward direction while passing through the runner. Okay, it means what, water flows radially, so गोलाकारात ते फिरत असतं बॉडीला. As the water passes over the rotating blades of the runner, both pressure and velocity are reduced. When water is placed on the blades, obviously its pressure and velocity are reduced. This causes a reaction force. Okay, a force perpendicular to the blades of the water is there, which drives the turbine. Okay, you can see here. Okay, two sets are there. These are the guide blades. Okay, they are the stationary part. These are the guide blades, and the rotating blades are there. Okay, we can observe here their rotating part is there. Okay, also in this figure, okay, these are the guide blades. Okay, when water comes, okay, from here, okay, water goes inside this. Okay, it will take path, okay, here like this. Okay, it will goes in between these two guiding blades. Okay, and then it will rotate. Okay, for example, in this part you can observe here the water is rotating. Okay, radial motion of water is there. Okay, radial motion. Okay, and this radial motion water when goes in, okay, it will be placed on that part. Okay, and it will rotate in clockwise direction. Okay, like this. Okay, so there are two sets. One is the guide blades and this is the rotating blades. Okay, this is the Francis type turbine. Next is the Kaplan turbine. Okay, here the vertical motion is here. Means water flow is vertical X. A Kaplan turbine is used for low heads and large quantities of water. Very large quantities of water are required, okay, with low heads, okay, means for earthen dam. Okay, in case of earthen dam, such types of turbines are used. It is similar to Francis turbine, except that the runner of Kaplan turbine receives water axially. Here, water comes axially, means what, upward. Okay, for example, in case water comes like this, okay, or vertical flow of water. Okay, at start you can observe this. Water flows radially inwards through regulating gates all around the sides, changing direction in the runner. Okay, you can observe here now. Okay, this arrow. Changing direction in the runner to axial flow. This causes a reaction force which drives the turn. Okay. In Kaplan, water coming from upward. And final part is the electrical equipment. Okay, means the turbine is mechanically coupled to the generator, and whatever the electrical energy generated by that generator has to be supplied to the grid, and for that substation and equipment installed in the substation are required. The electrical equipment of hydroelectric power station includes alternator itself with transformer, okay, to convert incoming power level to a desired power level, circuit breakers to break the alternate or isolate the alternator from the uh, grid when faults are there, and other switching and protecting devices. Okay, means protection of alternator is also required. Okay,